subtopic 1.1 factorability. Okay, so let's see the divisions in the integers. Okay, we already learned what is integers. Okay, integers denoted by this symbol Z. Dia ada dua ni lah. Okay, so integers, apa beza integers dengan real number? Integers dia punya range, okay, dia punya domain sama from negative infinity to infinity. But what is the difference between integer and real number is integer dia hanya melibatkan number, okay, number yang tidak melibatkan perpuluhan. Okay, 1.2 is not integer. Okay, 2, yes, integer. 2 is integer. Negative 5 also integer. Okay, perpuluhan bukan integer. Alright, so when an integer is divided by a non-zero integer, the quotients may or may not be an integer for sure. Okay, so for example, 15 divided by 3, you got 5. So 5 is integer. Okay, 5 is integer. But somehow, when you divide integer with a non-zero integer, okay, 13 over the 3, for example, 13 over 3, for example, is equal to 4.3333. So this is not an integer. Okay, not an integer. Alright, so definition: if A and B are integers with A is not equal to 0. Okay, we say that A divides B if there is an integer C such that B is equal to AC. Okay, A is not equal to 0. Okay, so B is equal to AC. If, okay, there is an integer C, so when A divides B, okay, when A divides B, kita pakai simbol. When A divides B, dia akan A divides B. Dia macam slash tapi dia straight. Okay, this is A divides B. Okay, ataupun dalam division dia adalah actually, okay, B divided by A lah. Dia bukan square root, divide. Okay, so we can say that A is a factor of B, okay, for sure, and also B is a multiple of A. For example, 2 divide 6. Okay, betul kan? 6 divided by 2, 3, right? Apa maksud divides? Divides adalah bila you bahagi. Okay, when you divide, this is a remainder. Remainder is equal to 0. So we can say that, okay, A divides B. A divides B. Okay, where 2 is a factor of B, which is a 2 is a factor of C, and also of 6, and 6 is a multiple of 2. Okay, that is a division in integer. So if A does not divide B, okay, so we use this symbol. For example, 3 does not divide 4. Why? Because of 4 divided by 3, okay, so the remainder is not 1, which is okay, not completely divides. Okay, completely divides means the remainder is equal to 0, right? Okay, so for example, determine whether 4 divides 9 and 7 divides 28. Okay, is 4 divide 9? Okay, 4 is not, okay, 4 not divide. Okay, 4 does not divide 9. Okay, so since 9 over 4 is not an integer lah. Okay, apa maksud not an integer? Okay, 9 divided by 4, we got 2 here, 8. So here, not an integer. Okay. Alright, so how about 7 divides 28? Okay. Kita ada ni, we have a B is equal to AC, right? B is 9, A is 4 times C. What is C? C is 9 over 4, which is not an integer. Inilah maksudnya. Okay, so how about 7 divides 28? Yeah, 7 divides 28. Since since you have B, 28 is equal to A, which is 7. C, what is C? C is 28 over 7, which is 4 is an integer. Okay, so 7 divides 28. Okay. Okay, so we have a theorem regarding to this method. Okay, let A, B, and C be integers. Then if A divides B and A divides C, so we can say that A divides B plus C. Okay, we have a 3 theorem. Okay, the first one, A divides B and A divides C, then we can conclude that A divides B plus C. Okay, for example, right. For example, 2 divide 4 and 2 divide 12. Okay, 2 divide 4 and 2 divide 12. And then 2 divides 4 plus 12. Okay, what is 4 plus 12? 4 plus 12 is 16. Is 2 divide 16? Yeah. Okay, now check. There, how to check it? Is B is equal to AC, 16 is equal to A to C. What is C? C is 8. So 8 is an integer. So, okay, this theorem is true. So we move to the second theorem. If A divides B, then A divides BC for all integer C. For all integer C. So if A divides B, then A divides BC for all integer C. Okay, for example, 4 divides 8, then 4 divides, 40. Okay, what is, means that this one is A divided B, so this one is A. How about B? B is 8. 8 times 5 lah. So your C is 5. So how about if we have 4 divide X? Then 4 divides 32. Why? A is 4. A is 4. Okay, here 8 times 4. So C is 4. C is 4, sorry. Okay, C for all integers. C. Asalkan dia adalah integers lah. As long as C is integers. Okay, kalau C is 8, yeah, for sure. 8 times 8, 64 divided by 4. So it is 16, right? So and the third theorem is if A divided by B, if A divides B and B divides C, so we can say that A divides C. A divides B and B divides C, then A divides C. Okay, for example, I use the smallest value. So 2 divides 6 and 6 divide 18. So we can say that's 2 divides 18. A divides B, B divides C, so we can say that A divides 18. Yeah, right? So if you use here B is equal to AC, you can find that C is equal to 9, which is integer. Yeah, so this is such example. You can see this example. Okay, throw in the notes in column. Okay, for your better understanding. So this is exercise. You may try to do it for your better understanding. So student, you have to do the exercise. Why? Because if you don't do the exercise, then you are not going to know whether you understand the lesson or not. Okay, when you start to do it, and then you understand whether, and then you will know whether you understand the lesson or not. Okay, if you are blank, means that you are not completely understand the lesson. Okay, all right. So we move to second subtopics of this chapter 1, which is primes. Okay, so primes is something interesting to explore it. Okay, so what is a prime number in general? Okay, it is a number that can be divided by 1 and also itself. Okay, again, what is a prime number? It is a number that can be divided by 1 and itself. For example, 2. 2 you can divide it by 1, and then also you can divide it by itself by 2. So how about 4? 4 you can divide it by itself, can divide it by 1, also can divide it by 2. So 4 is not a prime. Okay, prime only can be divided by 1 and itself only. Okay, all right. So all right. So we also have a composite. Okay. We also have a composite. Composite ni apa? What is a composite number? Composite number is a number that greater than 1 and it is not prime. For example, okay, greater than 1, yeah? Greater than 1 and not a prime. For example, 4. 4 is a composite. 4 is not a prime. 4, 6, 8. Okay, 10. 12, 15, 16, 18, 20, and so on are composite number. Okay, composite number greater than 1 greater than 1 and also not a prime number. Okay, okay, so we go more details. Okay, these are the list of primes that less than 100. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 20, 31, 27, 41, 43 until 97. Okay, so you have to memorize this one, not all, but a few that we have to know and memorize. Okay, so we go to prime factorizations. Okay, we have a few terms about prime factorization. Means that you factorize a prime number. Okay, the first one is the fundamental theorem of arithmetic, which is that every positive integer greater than 1 can be written uniquely as the product of primes. Okay, as a product of prime. For example, 6, yeah? 6, okay, is a product of prime, which is a 2 times 3. 2 is a prime, 3 is a prime as well. Okay, 6 is an example of product of primes. Another example is 18. Okay, it is 2 times 9, right? But bear in your mind, 9 is not an integer. Okay, sorry, 9 is not a prime. P stands for capital P stands for prime. 9 is not a prime, so you can convert it to prime, which is a 2 times 3 square. So this is a product of primes. Okay, all right. So second theorem. If n is a composite integer, then n has a prime divisor less than or equal to square root n. This one, I would like to ignore it. Okay, but it's very important is theorem 3, theorem 1 and theorem 3 are important. Okay, they are infinitely many primes. There are infinitely many primes. Okay. For example, 1001 if I'm not mistaken. For example, this one. 1024, it is a 2 times 2 times 2 times 2 times 2, which is a 2 power of 10. This is infinitely many primes. Okay, so that is a theorem 3. Okay, so let's see the examples of prime factorizations of 100. So 100, it is 2 times 2 times 5 times 5, okay, which is a 2 square times 5 square. So how to find the prime factorization? Factorization, it is like this actually. Okay, you have 100. Okay, you have to divide with the smallest value of a prime. Okay, 100, smallest value of prime. So prime you have a 2, 3, 5. So the smallest value that can be divided by 100, 2 lah. We have 5 and we have 2, right? But the smallest prime is 2, so divided by 2 you got 50, right? So 50, what are the possible primes that can be divided by 50? You have 2, 5, isn't it? Okay, completely divides 50. So smallest, so you choose 2. So you got 25. So what is the smallest, what is the possible primes that can be divided by 25? So for sure 5. So 5, so 50 divided by 2, you got 25 divided by 2, you got 5. 5 divided by 5. Okay, so 5 divided by 5. When you are going to stop when you got 1? Stop when you got 1. Stop. Okay, so the answer is the prime factorization of 100 is 2 square times 5 square. So how about 641? 641 is 641. Okay, prime factorization of 641 is 641. Okay, how about 999? 999. Okay, it is a 3 cubed times 37. Okay, this one same, you have to do this. Okay, method 999, the smallest one of course 3. Okay, 3 got 3, 3, 3. So divided by again 3, you got 1, 1, 1. Okay, and then divided by 3, you got 37, so 37, 37. Okay, so you got 1, so stop. Okay, so this is the answer for 999. How about 1024? We have discussed this one is 2 power of 10. So how about 7007? It is 7 square times 11 times 13. Okay, so okay, exercise, you have to try to do it. Okay,